Let us now first look at the first use of a potentiometer, that is to find the EMF of a cell. So this is the arrangement. Okay, you have the battery, the power source, then AB is the wire of the potentiometer. So AB basically is the potentiometer, remember, and we complete the lower circuit. So we have the cell whose EMF is E and which is required to be found. E we don't know. E is the unknown over here. Okay, R is the internal resistance of the cell. So it's like this is what the cell is made up of. All right. So these two components make up the cell. And the cell is then connected to a galvanometer, which is then connected to a jockey, remember. Now the idea over here is, what you need to do if you are working with a potentiometer, the idea is to find something called a null point. Now what is this null point? I had spoken about this null point when we did Wheatstone bridge principle also. Okay. Now what is this null point? By moving this jockey, by placing this jockey at different points on the wire, what you will see is this galvanometer starts deflecting. The moment you have this battery connected to AB, there will be current flowing in the upper circuit. Okay. Then if this jockey, like I told earlier, if the jockey is not connected to the wire, okay, then the lower circuit is incomplete. All right. In that case, the galvanometer is going to show no deflection because there will be no current flowing in the lower circuit and thereby no current flowing to the galvanometer. Now, the moment I place a jockey at some point, say for example at a point here close to point A, here at a point close to point A, say for example here, what you will see is the galvanometer will show a certain deflection like this. Say for example it deflects towards the left, and then after you raise a jockey from this point and you place the jockey at some point over here, say for example at point B, you will see that your galvanometer will show a deflection in the other direction. If the connections are done properly, this is what will happen. First, when you place the jockey at one end, okay, you will see the galvanometer deflects towards one direction, whatever direction it be. Here I'm saying it deflects towards the left. Okay, then after I place the jockey to the other end, we will see that the jockey deflects towards the opposite side now. So what happens is at the two ends, when you're placing the jockey at the two ends, we are seeing that the galvanometer deflects in two opposite sides, two opposite ends, which means there has to be a point somewhere in between these 2 points. There has to be a point where the galvanometer will show no deflection. There has to be a point somewhere in between these 2 points where the galvanometer shows no deflection. Now, that is what we need to find. That point is what we need to find. Okay. So trial and error goes on. I go on. Then after initially I placed my jockey very close to A and very close to B. Then after I place it somewhere over here. Then after it will still deflect towards the left. Then after I'll place it somewhere close to B, it'll deflect towards the right. So which means the null point has to be somewhere in between this point and this point now. So I go on reducing my range over here. So I place it over here, deflects towards one side. Place it over here, deflects towards the opposite side. Okay. So this way I go on decreasing my range over here. Okay. And thereby I eventually land up at the null point. So the basic idea is to find the null point, remember. Okay. So once I find the null point, what happens is null point means, which is the case when no current flows through the galvanometer. Finding null point means there is no current flowing through the galvanometer. The only reason the galvanometer deflects is because there is current flowing, because the galvanometer is sensing current, detects current. So therefore it deflects. The moment it detects current, it deflects, remember. So since the galvanometer is not deflecting now, at the null point, the galvanometer is not deflecting, which means there is no current flowing through the galvanometer. This is what we need to find, remember. Okay, so once null point is found, okay, once there is no current flowing through the galvanometer, what is true then after? Okay, then after what happens? Since no current is flowing through the galvanometer, no current is flowing in the lower circuit, which means, okay, which means the potential difference across, listen to me very, very carefully now, the potential difference across AJ, this potential difference has to be the potential difference across CD. Okay, only when there is potential difference, current flows only when there is a certain potential difference. Okay, so if the potential difference across AJ is the same as the potential difference across CD, there will be no potential difference, so to say, between these 2 points, D and J. Okay, so there will be no current flowing through the galvanometer in that case, remember. Okay, so this is what is true. At null point, the potential difference, delta represents the difference. So delta VAJ, the potential difference across AJ, has to be equal to the potential difference across CD. Okay, now what is potential difference across AJ now? This length is L, the whole length of AB is L. Now this is the null point, this is the null point. Say for example, the position of the null point is X, the length of the null point, the distance of the null point from point A is X. Okay, so what is potential difference VAJ? The potential difference VAJ is V upon L into X. Why? Because I have already shown you, for length L, the potential difference is V. For this whole length AB, the potential difference is V, the thing that we've applied. Okay, so for unit length, it will be V upon L. Alright, so for length X, it will be how much? For length X will be V upon L into X. So that is exactly what I've written over here. Potential difference across AJ is V upon L into X. And what is, now this is what you need to understand. Okay, potential difference across VAJ is V upon L into X. And potential difference across CD. Now what is the potential difference across CD? Okay, now see, the EMF of this cell is E, which is to be calculated. We are calling it E. Alright, now since there is no current flowing, in the lower circuit, there is no, this is the internal resistance R, there is no voltage drop across this resistor, internal resistance R. Okay, alright. So because of which, what happens is the potential difference across CD will simply be E. Okay, yesterday we've seen that we have a cell, okay, and we have a resistor. If I measure, this is the internal resistance of course, if I use a voltmeter to measure this, the EMF, the voltmeter is going to read what? The voltmeter is going to show me the voltage, the voltmeter is going to show me the terminal potential across these two ends, across the ends of the battery or the cell. Okay, because the EMF was what? The EMF was the terminal potential plus the potential drop or the voltage drop across the internal resistance. So what is the terminal potential? Terminal potential is E minus I into R. This is the terminal potential, and this is what the voltmeter is going to measure. Remember that. Okay, so here the potential difference across CD would also be this. This is the potential difference across CD, would also be this if there was current flowing through the internal resistance. But since there is no current flowing through the internal resistance, okay, the potential difference across CD will simply be E, because I is 0. Remember, galvanometer is showing no deflection. This is the case of null point. So therefore there is no current flowing through the internal resistance. So therefore the potential difference across CD will simply be E. Remember that. Okay, so therefore the potential difference across CD is E. So since at null point these two things are to be the same, okay, for no current to flow, the potential difference across the potential difference across AJ and the potential difference across CD are to be the same. So therefore the EMF of the cell will simply be E, which is V upon L into X. Okay, in your book you will see E is K into X. Okay, V upon L can simply be measured, okay, knowing this V, alright, knowing the length L, which can of course be measured by the scale, don't forget, Okay, so V upon L can be measured and X can be measured. So therefore the EMF of the cell can be determined.